Welcome to Ask and Learn.
We are given a linear recurrence relation that does not have constant coefficients. We are asked to solve this recurrence relation. The relation is n plus 1 times an is equal to n plus 3 times an minus 1 plus n for n greater than or equal to 1, and it has the initial condition that a of 0 is equal to 1. From a previous exercise, we have that if we take f of n to be the function n plus 1, g of n to be the function n plus 3, and h of n to be the function n, then we have that a of n is equal to the initial value, which is 1, plus the sum from I equals 1 to n of q of I times h of I all over g of n plus 1 times q of n plus 1, where q of n is equal to f of 1 up to f of n minus 1 over g of 1 up to g of n. So we have that in particular h of I is just I, g of n plus 1 is going to be n plus 4. We want to find what q of I is, so in this case q of n is going to be equal to, well, we have f is n plus 1, so this is going to be n plus 1 evaluated at 1, which is going to be 2. Then f of 2 is n plus 1 evaluated at 2, which is 3. We want to multiply all these together all the way up to n minus 1 plus 1, which is n, all over g of 1 is 3 plus 1, which is 4, and then times 5 all the way up to n plus 3. And so this can be written, if we divide out common terms, as 2 times 3 over, and then we have left over n plus 1 times n plus 2 times n plus 3. And so we have that an is equal to 1 plus the sum from I equals 1 to n of 2 times 3 is 6 over I plus 1 times I plus 2 times I plus 3 all over g of n plus 1, which we know is going to be n plus 1 plus 3, or n plus 4, times q of n plus 1, which is going to be 6 over n plus 2 times n plus 3 times n plus 4. And this can be written, well, first of all, in the numerator, we have that this sum here is not easy to evaluate And we could use induction to find this, but instead you can also use a computer algebra system to evaluate. On my mistake, this should be times h of I, which is simply I here. So we have 6i over I plus 1 times I plus 2 times I plus 3. And using technology, we'll get that this is going to be 1 plus 3n times n plus 1 over 2 times n plus 2 times n plus 3. But again, you could use induction if you wanted to prove this. And then in the denominator, we have the n plus 4's cancel out to give us 6 over n plus 2 times n plus 3. And then multiplying the top and bottom by n plus 2 times n plus 3, we get n plus 2 times n plus 3 plus 3n times n plus 1 over 2, all divided by 6. And then multiplying the top and the bottom by 2, we get this is 2 times n plus 2 times n plus 3 plus 3n times n plus 1 all over 12. And foiling, we get 2 times n squared, and then we have 5n times 2 is plus 10n, and then 6 times 2 is 12, plus 3n squared plus 3n, all over 12, and this is equal to, we have 2n squared plus 3n squared is 5n squared, so 5/12 n squared, 10n plus 3n is 13n, plus 13/12 n, and then 12 over 12 is simply 1, so plus 1. And so we have that an is going to be equal to 5/12 n squared plus 13/12 n